The fourth question says, a passenger is standing at a distance d meters from a bus. The bus begins to move with a constant acceleration a. To catch the bus, the passenger runs at constant speed u towards the bus. What should be the minimum speed of the passenger so that he may catch the bus? We'll do this problem based on a frame of reference fixed on the bus. So this is where we have our frame of reference. In that case, we'll consider the bus to be stationary and we'll apply the corresponding corrections on other moving particles and do this problem. So since we are doing this problem based on a frame of reference fixed at the bus, we'll find out the relevant parameters of the other moving body, that is the passenger, with respect to the bus. Now, the first parameter that we look for is the relative acceleration of the passenger with respect to the bus, that is APB, that is AP minus AB. Now, AP, the acceleration of the passenger, is 0 because he is traveling with a constant speed u, that is 0, minus acceleration of the bus. The bus has a constant acceleration, that is towards right. It is given in the question. The bus is moving with an acceleration a. So AB is simply a. So finally you have minus a here. That's the first parameter. The second parameter is the relative initial velocity of the passenger with respect to the bus. That is UPB. And that again will be equal to UP minus UB. The initial velocity of the passenger is u. And the initial velocity of the bus will be 0 because the bus is starting to move. It is starting from rest with a constant acceleration. So since it is starting to move, it is at rest initially. So we'll put UB is equal to 0. So this here becomes u. Now, if the passenger should catch the bus, the relative displacement between them, or the relative displacement of the passenger with respect to the bus, should be d distance forward. It is very clearly marked in the question. D distance forward, and that will be SPB directly is d distance forward. The bus is stationary. The passenger has to move to the right to catch the bus. So that relative displacement has plus d. SPB will be equal to plus d. Now is the most interesting part here. We need to find the minimum speed of the passenger so that he may catch the bus. Please understand that if the passenger is very fast, the passenger is moving with a very high constant speed, he may cross the bus, and since the bus is slowly accelerating, the bus will pick up speed and then cross him back. That is not the case that we need. And there is also another possibility that if the passenger is not fast enough, he may never reach the bus before the bus picks up speed and goes away. So what we need is a minimum speed with which the passenger should travel so that he can just catch the bus. And in that case, please understand that that minimum case refers to the condition where the passenger crosses or covers the relative displacement d, and at that point, both the bus and the passenger would have the same exact velocity. Otherwise, the passenger would overtake the bus. That is not the minimum case. Of course, still he can catch the bus. But the exact case that we are looking for is a case where when the passenger covers the distance d, the bus and the passenger would exactly have the same velocity. So the relative velocity in that case will be 0. That is the case for minimum speed with which the passenger should travel. So for the minimum velocity case, V relative or VPB should be equal to 0. That is when the passenger can catch the bus with the minimum effort, with the minimum velocity with which he can travel. Now, if that is true, we can use the equation V square is equal to U square plus 2AS. In relative terms, it will be VPB square is equal to UPB square plus 2APB SPB, and that can be expanded or replaced with the corresponding values as 0 here is equal to u square plus 2 into APB is minus A into SPB is D. In that case, we have 0 is equal to u square minus 2AD. We need to find the value of E, the expression for E. That gives us 2AD is equal to u square, or u is equal to root 2AD. That is how we solve it.